Hey guys, I'm back. So today I'm going to be sort of explaining how you can make a voltage regulator with this Mosfet. I just showed the circuit and I'm using an IRF 640 Mosfet. Here's the circuit, just with the LM324 op amp, and this is the power supply that's powering it. And so I've taken, and this multimeter, oh, well, I'll get to that later. Anyway, I've taken this standard schematic of a regular voltage regulator with NPN transistors because somebody in the comments of one of my voltage regulator videos asked me why they don't use a MOSFET, so I set to find out. So I took that circuit right there and instead did this one, so I just literally plopped in a MOSFET right where the NPN Darlington used to be. So I didn't make any configurations to use the MOSFET differently. So I figured I would just test with this basic schematic. And here's the MOSFET. And that wire that I'm tapping now, sorry, the green ones are the ground, common ground. The yellow one that I was tapping goes to the power supply, and that wire goes to, that's the power supply that's powering everything. That yellow wire on the right is going to another power supply, which I'm using as the reference voltage, because if you remember from my past voltage regulator videos, the op amp will track the output to match the reference voltage. So in this case, I have a variable reference voltage set by that power supply on the left there. So ideally, in a perfect world, these two should match. Okay, so, and if they match, that means the regulator is working properly with a MOSFET. So here we go. As you can see, we have it at about 1 volt on the left. I know it's not quite in focus, but as you can see throughout me turning it up, you can see they pretty much match throughout the whole thing. Now once we hit, now where as you can see 1, 2, 3, 4, 5, we're at about 5, right? As you can see, obviously I'm at an angle, so it's not going to be about, it's not going to be super accurate on this analog meter. However, it says 5.10, and that's what the meter was reading. Now at a certain point, the voltage won't go above 5.75, no matter how high I tune it. And that's because the supply voltage is too low. However, the supply voltage is about 9 or 10 volts. So one of the reasons I can think why you wouldn't use a MOSFET is that with NPN transistors, you have about, an NPN Darlington, you have about 1.5 volts dropout. With a PNP, single PNP, which is what they use in LDOs, you have about half a volt dropout. With a MOSFET, you have like 4 volts dropout. So that's one of the reasons not to use a MOSFET. And that's because the gate voltage of the MOSFET needs to be at about 4 volts until the thing will turn on. So that's how you have that big dropout, is the turn on voltage of the gate. And even the best MOSFET will only be about 2 volts, which isn't as good as an NPN. So that's why it won't go above that. But other than that, it tracks actually very well. It's not super good because I don't have any capacitors, which we'll get back to, so the loop is a little bit inherently unstable. However, if you added capacitors, so those issues would be taken care of. And after this, it's hardly warm at all. And that's the power supply that's powering everything, about 10 volts, like I said. And now I've added an 8.2 ohm resistor, and I've set the voltage to about 4 volts. So we're going to put this thing under about roughly 500 milliamps load, and we're going to see that it's about 3.6 volts with load, and 4 without load. Now you notice when there's load, the voltage is climbing up. I tested with a capacitor, and it only changed by about 10 millivolts. So capacitors on the input and output, I was testing with the 33 and a 270, and it seemed to work better with 33. So I would say fairly high capacitance, 33 volts, and your loop will be much more stable, and your current regulation will be better. However, I can see why they don't use MOSFETs. One is because since the gate voltage to turn on the gate is so high, you can have 3-4 volts dropout voltage, which is pretty useless. Also, even with capacitors to stabilize the loop, even with 500 milliamps, right? Well, that's not a super amount of current. That's not a nothing current either. But with that much, it drops about 0.4 volts. Without capacitors and with caps, it drops 0.1 volts. So, maybe at 2 amps, 0.1 volts is acceptable. However, that's a lot of voltage to drop. And it also got up to about 120 degrees when the ambient temperature in the room was about 70, 75, regular room temperature. So it got fairly hot at a 500 milliamp load. So that's why they don't use MOSFETs in voltage regulators. However, you could, if you wanted to, just be where your dropout voltage is going to be very high in your MOSFET, and you're going to need You know, I bet you that the higher current, the more capacitance you need to keep the voltage tracking still, because if it's not tracking and the output voltage gets loaded down, that's bad. That's current loading. So I suspect that you'll need a higher capacitance, the higher load. So it's doable, but that's why they don't do it.